Hello and welcome to Algebra 2 Practice Set 38. In this video, we're going to look at some additional practice problems for our lesson on synthetic division. All right, so we want to find each quotient using synthetic division. All right, so for the first one, we're looking at 14a to the fourth power plus 19a minus 8a squared plus 46a cubed minus 30 plus a to the fifth power. This is over a plus 6. So the first thing we want to do is we want to put things in standard form, and we want to account for any missing powers of our variable. So I'm going to put equals here, and the highest exponent is a 5. So I'm going to lead out with a to the fifth power. Then I'm going to go plus 14a to the fourth power. Then next we're going to have plus 46a cubed. Then next we're going to have minus 8a squared. Then we're going to have plus 19a. And lastly, we're going to have minus 30. So I'm not missing any powers for a. I've got fifth power, fourth, third, second, and first. So I'm good there. And it flows correctly, so it's in standard form. Then this is over. Now we have a plus 6. Now, what I'm going to do is I'm going to write this as a minus a negative 6. Hopefully you watched the lesson, and you know that when we're doing synthetic division, we want the divisor to be in the format of x minus k. So we want this sign to be a minus, okay? So if you see a variable plus something, you use this little trick and you put minus and negative to transform it into this format. Now, I have a minus a negative 6. So now that that's done, what I want to do, I want to set up my little long division symbol. And I just want to take the numerical information from the dividend, or the numerator, if you want to call it that, and I want to place it inside here. So I'm not going to include any of the variables. So the coefficient for a to the fifth power is a 1. So I'm just going to put a 1 here. Put a little bit of space. Then the coefficient for a to the fourth power is a 14. Then we'd have a 46. Then we'd have a negative 8. Then we'd have a 19. Then we'd have a negative 30. Okay? So all the numerical information is in here now. Now off to the left here, all I want is this negative 6. Remember, if it's in the format of x minus k, I want whatever k is. So you have minus and then negative 6. So that's what we have for k. So that's going over here. That's negative 6. All right. So now I draw a little bar down here, and I bring the first number down. After I've done that, all I'm doing is multiplication and addition. Very, very simple. So what we want to do is start out with negative 6 times 1. That's negative 6. Then I want to add. 14 plus negative 6 is 8. Then I want to multiply. Negative 6 times 8 is negative 48. Then I want to add. 46 plus negative 48 is negative 2. Then again, I want to multiply. Negative 6 times negative 2 is 12. Then I add. Negative 8 plus 12 is 4. Then I multiply. Negative 6 times 4 is negative 24. Then I add. 19 plus negative 24 is going to give me negative 5. Then I multiply. Negative 6 times negative 5 is 30. Lastly, I add negative 30 plus 30 is 0. The numbers down here represent numerical information for the answer. Now the answer here, the polynomial, will be 1 degree less than the dividend. Here the degree was 5 because the highest exponent was a 5. This one would be a 4. So starting all the way to the left, this is the coefficient for a to the fourth power. Then this would be a cubed. This would be a squared. This is a. This is your constant. You could say a to the power of 0 if you wanted to. And then all the way to the right, this is always the remainder. Okay, this is the remainder. Now in this case, the remainder is 0, so we just don't have one. So to write our answer, we would say you have 1 times a to the fourth, or just a to the fourth. Then plus 8 times a cubed, so 8a cubed. Then minus 2 times a squared, so minus 2a squared. Then plus 4a, then minus 5. And that's your answer. So you have a to the fourth power plus 8a cubed minus 2a squared plus 4a minus 5. All right, let's take a look at the next problem here. So we have 43n squared minus 29 plus 45n minus 14n cubed plus n to the fourth power. This is over n minus 7. So again, I want to put this in standard form, and I also want to account for any missing powers of the variable. So I'm going to start out with n to the fourth power, since 4 is the highest exponent. Then next I want to do minus 14n cubed. Then I want to do plus 43n squared. Then I want to do plus 45n. Then I want to do minus 29. And this is over. We have n minus 7. Again, what I want to do is take the numerical information from the dividend. So I'm going to make my little long division symbol. My numerical information, I start out with this. I have a 1 as the coefficient for n to the 4th power, so I put a 1. I've got a negative 14 as the coefficient for n cubed, so I put a negative 14. So on and so forth. So I put a 43, I put a 45, and I put a negative 29. Now, biggest source of confusion. This right here, remember, what am I going to put here? If it's in the format of some variable minus some number, so x minus k, for example, this is what goes here. This perfectly matches that. N minus 7, I'm going to put 7 in. Not negative 7, just 7. Okay? Very important you understand that. If it's a variable minus a positive number, just put that number in. If it's a variable plus a positive number, it's going to be the negative of that number. All right? So that's the biggest source of confusion. So once we have this set up, put our little bar down here, bring down the first number, and then we're ready. We're just going to multiply, then add, then multiply, then add, right? Just keep going until you get to the end. We start with multiplication. 7 times 1 is 7. Now we add. Negative 14 plus 7 is negative 7. Now we multiply. 7 times negative 7 is negative 49. Now we add. 43 plus negative 49 is negative 6. Now we multiply. 7 times negative 6 is negative 42. Now we add. 45 plus negative 42 is 3. Now we multiply. 7 times 3 is 21. Now we add. Negative 29 plus 21 is going to give me negative 8. So again, this number all the way to the right is the remainder. Now I can work my way left and say, okay, well, this is the constant. This is the coefficient for n to the first power. This is the coefficient for n squared. This is the coefficient for n cubed. I can also start left and work right. I know that it's 1 degree less than the dividend. The degree here is 4, so I know the degree here would be 3. So your highest exponent would be 3. So you'd start out with n cubed, then n squared, then n, your constant, your remainder. So however you want to think about that. All right, so let's write our answer now. We would have 1 times n cubed, or just n cubed, then minus 7n squared, then minus 6n, then plus 3, then plus, we'd have negative 8 over, remember our divisor was n minus 7. So this is your answer here. You end up with n cubed minus 7n squared minus 6n plus 3 plus negative 8 over n minus 7. All right, for the next one, we're looking at 7x plus x to the 5th power plus 4 plus x to the 4th power over x plus 1. So again, I'm going to rewrite my numerator and denominator in standard form. So I'm going to start out with x to the 5th power, then plus x to the 4th power. I'm missing x cubed and x squared. So I'm going to put plus 0x cubed plus 0x squared, and then plus 7x, and then finally plus 4. And this is over. We have x plus 1. Again, I want this in the format of x minus k. So I want this to be a minus. In order to do that, I do a little trick and I say x minus a negative 1. Minus a negative 1 is the same as plus 1. Okay? So now this is my value for k. Okay, that's what I'm going to use when I set up this synthetic division. All right, so now that we have this information ready, let's go ahead and plug it in, set up my long division symbol, and again, I just want numerical information. So from the numerator, I want the coefficients for x to the 5th power, which is 1, then x to the 4th power, which is 1, then x cubed, which is 0, then x squared, which is 0, then x to the 1st power, which is 7, and then my constant term, which is 4. Then, what is my value here? Again, k here is negative 1, so I'm plugging in a negative 1 there. And again, if you have x plus some positive value, it's going to be the opposite of that positive value, just like we have here, because we rewrite it in the format of x minus the negative of that value. So the negative of 1, or negative 1, is what goes right there. Okay? Very important, again, that you understand what goes here. This is the biggest mistake I see. All right, so let's bring this first one down. 1 comes down, we multiply. Negative 1 times 1 is negative 1. Then we add. 1 plus negative 1 is 0. Then we multiply. Negative 1 times 0 is 0. Then we add. 0 plus 0 is 0. Then we multiply. Negative 1 times 0 is 0. Then we add. 0 plus 0 is 0. Then we multiply. Negative 1 times 0 is 0. Then we add. 7 plus 0 is 7. Now we multiply. Negative 1 times 7 is negative 7. Now we add. 4 plus negative 7 is negative 3. So this is my remainder. This is my constant. And if I don't go this way, if I don't say, okay, well, this is going to be my x to the first power, I could go back up and I could say, well, the highest exponent on x here was a 5. So the degree of this polynomial was 5. So the degree of this will be 4. So if I come back down here, I could say, well, I know this is the coefficient for x to the fourth power. Then this would be the coefficient for x cubed, x squared, x to the first power. Of course, we could have went this way as well, just another way to kind of look at it. And we can write our answer. You'd have 1 times x to the fourth power, or x to the fourth power. You'd have 0x cubed, and 0x squared, and 0x. So you don't need to put any of those. Then plus 7, then plus, you'd have negative 3 over. Remember, your divisor here was x plus 1. So over x plus 1. So this is our answer. We have x to the fourth power plus 7 plus negative 3. Again, over that divisor of x plus 1. All right, let's take a look at one final one. So we have 43b plus 23b squared plus 7b to the fourth power plus 38b cubed plus 20. This is over b plus 5. So again, I want to write everything in standard form and account for any missing powers. So I don't have any missing powers here. I'm just going to write everything in standard form. So 7b to the fourth power, then plus 38b cubed, then plus 23b squared, then plus 43b, plus 20, and this is all over b plus 5. Again, I want this to be in the format of x minus some value. So I can change this to b minus a negative 5. This is my value for k. This is what I'm going to put to the left of that long division symbol when I do my synthetic division. Let's make our long division symbol. And we're just going to use our numerical information. So we've got a 7, we've got a 38, we've got a 23, we've got a 43, and we've got a 20. All right, so that's set up. And again, my k is negative 5 here. So I'm going to put that over here. So this is negative 5. And I'm going to make my little bar here. I'm going to drag this down, and we're going to begin. And remember, multiply, then add. Multiply, then add. You keep doing that until you get to the end. Negative 5 times 7 is negative 35. 38 plus negative 35 is 3. Negative 5 times 3 is negative 15. 23 plus negative 15 is 8. Negative 5 times 8 is negative 40. 43 plus negative 40 is 3. Negative 5 times 3 is negative 15. And then 20 plus negative 15 is 5. Let's scroll down a little bit. So again, this is our remainder. Then this 3 right here would be my constant. Then this would be my coefficient for b to the first power. This would be my coefficient for b squared. This would be my coefficient for b cubed. So if I wanted to write my answer, I could say it's 7b cubed plus 3b squared plus 8b plus my constant, which is 3, plus 5, my remainder, over the divisor here was b plus 5. So b plus 5. All right, so this is my answer. Again, one more time, it's 7b cubed plus 3b squared plus 8b plus 3 plus 5 over b plus 5, that divisor.